Hi, just wanted to take a few minutes here today to review a couple of the key points around nitrogen stabilizers from the nitrogen stabilizer meeting with United Co-op in February. If you remember, the main goal around nitrogen stabilizers is how do we address nitrogen management so that we keep our nitrogen in the root zone until that crop really truly needs it, which really doesn't begin until middle part of June. So that's a long time often from when we actually make our nitrogen applications. So we just wanted to go through a quick visual on how some of the different nitrogen stabilizers do work to protect that nitrogen until the crop truly does need it. So one of the main ways that we lose our nitrogen applications in central Iowa is through a process called leaching or denitrification. And both of these happen when we have soil microbes breaking down our stable ammonium into a version of nitrogen called nitrate. Once we break things down into nitrate, that nitrogen is repelled by the soil particles and freely moves in water or is susceptible to turning into gas through nitrogen or denitrification and going up into the atmosphere. So the key is if we keep our nitrogen in the stable ammonium form, neither of those processes can happen as quickly. And we can delay that process until the crop has a root system established to take up that nitrate. So what we're going to look at here is how easily it is in this form of leaching for that nitrate to move. So here in this blue dye, we've got a solution that has a positive bond, which is going to be the same as what ammonium is. And so when we pour this through the soil profile, that negative charge in the soil is going to attract to that positive charge with the ammonium, and they're going to hold each other there. So for that to happen, no amount of water is going to be able to move that magnet-like charge. So I'm going to pour this solution through my soil profile. So what we'll see is as that water moves through the solution, that bond with that positive charge with your nitrogen in the ammonium form and that negative charge with the soil will hold tight together. And even though there's water moving through that profile, that nitrogen will stay in that top few inches of the band of your soil. Now conversely, if we allow our nitrogen to convert into nitrate and we get too much water or too much rain, that negatively charged nitrate will flow freely with the water. And what that happens is when we do have some of those big 4-inch rains that we so often get, that nitrogen is going to move down through the profile and is potentially going to be too far away from your crop's roots to capture it and bring it back into your plant. And the last piece I'm going to show you here is a combination of positive and negatively charged nitrogen. So this would kind of represent what we have when we talk about applying UAN solution to the soil. So you're going to have some ions in here that are positively charged that will attract to the soil and some that are already in that nitrate form. And so what we're going to see here as this water starts to flow through our soil profile is as we have water come out the other end, over here where we kept things in that positive charge, so that very stable charge, even though we dumped in blue dye, we're going to have clear water come out the other end because that nitrogen is stable in the solution. Where we allowed that negatively charged nitrate to happen and convert, our liquid is just as orange as what it was when we poured it on top, representing that nitrogen moving down and away from our root system. And as we allow this mixture over here to flow through the soil, we'll get a very similar orange color with that nitrate as it flows through, while we'll still keep our blue dye that was positively charged in that top solution. So what does that mean? So what that means is when we're actually thinking about our nitrogen applications, there are certain products that allow us to keep our nitrogen in this stable form longer. So if you're thinking through your main nitrogen sources, so if it's anhydrous, a product called N-Serve keeps our nitrogen in this form longer by preventing that breakdown to happen. If you're using UAN or manure as your main source, the product would be Instinct that would also work the same way. In keeping our nitrogen in this stable form longer into the growing season to allow our uptake to match when that crop truly does need that nitrogen. What's really neat about this example is notice though, even though I had probably 5-6 inches of this solution I dumped into this profile here, representing a big rainfall. That bond is so strong between that positive and negative charge that I've trapped all of that nitrogen in the top couple inches of my profile. When we look at our nitrate or our negatively charged nitrogen, with that same amount of rainfall, I've now totally filled that profile and allowed nitrogen to exit the root zone as it's moved further into the soil profile.